if we are going to do pure math P1 2026 January exam, you must be able to answer these questions that I'm going to take you through. This is a prediction of pure math, so let us go straight and get to see what are the kind of questions or topics that you expect in this coming exam. So this paper is usually 75 marks, and the paper takes right, so let's get started. One of the concepts that you must be well prepared to answer is the concept to do with integration. And under integration, you are going to be given basic integration, whereby you are given an expression like this one that we have here, and then you are supposed to integrate and give your answer in a simplified form. You may be given a question that includes square roots like that, or an expression that include brackets, whereby you must expand then start performing the integration. So make sure you are ready to answer any part. An expression that look like this, then you integrate, or you are given brackets where you are supposed to expand and then integrate. Now, when you are given this one, what you need to understand is that you need to divide every term by what is in the denominator and then simplify that using indices. And you can see that's why I decided to ensure that I'm going to take this term, I divide by x squared, and also this term I divide by x squared. So everything simplified very well, and I got my simplified expression as 2x raised power negative 1.5, and that is basically because 1/2 minus 2 gave me that, and then I integrated. So what you need to understand for integration, if you are having x raised to power n and you are integrating this with respect to x, yeah, so meaning you are going to increase the power by 1, so it will be x, I think my software is a bit misbehaving, x raised to power n plus 1 over the power that you have gotten n plus 1. Yeah. So that's exactly what I did. I took negative 1.5 plus 1 over the answer I got. Yeah, you can see that, right? So basically I need to have mentioned here that this is basically minus here, because if I took minus 1.5 plus 1, I must have gotten 0.5 negative, and then basically here this will be a negative seated here, and there will be a negative seated here, and our expression, all my expression, is going to reduce to that. So you can see you can easily mess with negative signs there, here and there. So those are the areas that you really need to be very careful when you're going to sit for this exam. Now, upon mentioning integration, the next area that you may be expected to work out is question to do with solving quadratic and also solving cubic functions. And you can see in this case what I did with this expression that I was given here. I really decided to factor x out, and once I factor out x, I'm going to remain with a quadratic equation inside the bracket here. Yeah, so I factored x out, and then I was able to remain with a quadratic equation which I could solve, because if I factored x out, it means that I'm going to say x is going to be equals to 0, and also this quadratic that I'm having here is also going to be equals to 0. Then if you solve that quadratic, you're gonna get your answer x is equals to minus 5, and x is 2x minus 7 is reducing to 3.5. So what I'm trying to say at this point is that ideally you really need to understand how to solve quadratic and also how to solve cubic functions for you to be very comfortable doing that particular exam. And also, if you are new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to do further tutorials, you'll be notified. I'll be doing more predictions, and also I'll be taking you through P2, P3, P4, and further pure math as well as physics. So you'll have every reason to be in ProfLearn, to stay here, so that when I'll be taking you through all those concepts, you'll be notified. All right, so moving further, when you may be expected also to work out questions that looks like this. You can see this expression that we are having is power 6, power 1, power 2. And what I just did here, I decided now to let u be equals to whatever we have inside here, which is y minus 5, and this is raised to power 2, so that if I rewrite this equation, it will be the same as the equation that was given there. So using this approach, it will be very important because it will enable you to use the answers that you got in the previous part in order to get the answer to this. So how are we going to? Because you can see this equation that in terms of u now, it becomes of this. So we can be able to say that if you solve this, you are going to get u is equals to 0, u is equals to -5, u is equals to 5/2. So that is exactly what you are going to get at that point. Just like the way we had gotten x is equals to 0, x is equals to -5, x is equals to 3.5 all 7/2. So once you have gotten that, now you are going to say u is equals to that. Then therefore, because u was equals to 7, y minus 5 squared is equals to 0. If it is equals to 0, then we can be able to find the value of y. And then if u is equals to -5, then it means since it was a substitution, then y minus 5 squared should be equal to -5. But this is mathematically wrong, because there's no way you can square a number and then you end up getting a negative value. So basically you cannot get that. Okay, if you're new to ProfLearn YouTube channel, consider subscribing so that anytime we are going to do other tutorials, you'll be notified. All right, so let's proceed so that we can be able to see what is the next part. So the next concept is differentiation. So under differentiation, you may be given expressions like this, whereby you are given fractions and then you're supposed to differentiate. But you remember in P1 you've done basic differentiation, and you're going to do term by term differentiation. So meaning this expression that we have at this given point, you are supposed to simplify it by taking the denominator divided to every term that is in the numerator. So once you've done that, you realize that this expression can reduce to y is equals to 5/2 x minus 4x squared x raised to power -2. Then we can differentiate now term by term. If you differentiate this, it becomes 5/2. And if you differentiate this, remember when you differentiate, you take the power, you take it down, so that you multiply -4 times the power that is there. Then once you've taken the power down, you subtract 1 from that power. So meaning that it's -2 minus 1 becomes -3, and this is the expression that we have. That's now we have simplified. Another way this question can be asked is where you are given expression with brackets. The main means that you need to expand, then you differentiate. Next, find the equation of the tangent to C at P. We are given that at P, at P, the coordinate is 2, 4. Then we are supposed to find the gradient at 2. Once you find the gradient at 2, yeah, we are going to have it as 7 over 2, which is the same as 3.5. Then now we can be able to find the equation of the tangent, because the tangent and the curve, they have the same gradient. So since the gradient of the curve at 2 is 7 over 2, then it means also the gradient of the tangent is 7 over 2. So you'll go ahead and work out the equation of the tangent using this formula that I've highlighted here. This is the general way of finding the equation of a straight line, which is y minus y1 is equals to m. M is the gradient, and x and x1 is the coordinate that you know. For this case, the coordinates that we know here, where the line passes, is 2 and 4. So we are going to assign this, we shall assign this as x1, and we shall assign this as y1. If you are having two coordinates, you can choose any of them. But since we were having this one, we are going to assign x1. So meaning this is y minus 4, which is y1. Gradient is 7 over 2, then also x minus 2. If you simplify that, you're going to get your answer like that. And always, when you are going to sit for that exam, make sure you are checking in which form you are asked to give your answers, so that you know in what is the final answer, in which format you are going to write your final answer, and that will enable you score all the marks without losing any mark. Now, another concept that you need to also prepare for this exam is finding the equation of the normal to the curve. So in that case, you see this one, we were to the tangent, so we use the gradient that we were having here to find it. But if they're going to ask you to find the equation of the normal, something that you need to remember is that the equation of the tangent times the equation of the normal should give you -1, or the gradient of the tangent and the gradient of the normal should give you -1. And also that means that the gradient of the curve times the gradient of the normal must give you -1. So those are the key concepts that you need to remember. So at that point, if we were being asked to find the equation of the normal to the curve at this point, we were to go an extra mile, take 7 over 2 times m2 is -1. We find m2, and then we proceed with the same steps to work this question out. Is that clear? Great. Moving down, you must know how to use the cosine rule and also sine rule. Remember, sine and cosine rule are used to find sides of triangles or angles of triangles where you don't have a right angle triangle. But SOHCAHTOA enables you to find those sides or angles when you have a right angle. So use cosine rule to find the value of sine theta. Now I was given a triangle here, then I developed the diagram, and I say now cosine rule, sine rule is sine x over the side is equals to sine 25. You see now the opposite side is this, and the opposite side for x is this. So that is why I say now sine x over the opposite side is equal to sine 25 over the opposite side, which is 13. So if you work it out, you're gonna get sine x is equals to 0.6827. Then candidates were expected to find the value of x, and this is to find the sine inverse, which becomes 43.05. But since this angle is more than 90, then now I said it should be 180 minus 43.05, which becomes 136, because we know sine is positive in the first quadrant and also sine is positive in the second quadrant. So meaning that now if you have the angle that is in the first quadrant, to get the size of that angle in the second quadrant, you are going to use this concept that all students trust Cambridge University. That's why most of the students will want to go there. So if we have gotten this angle here is 43.505, then this, because of symmetry, also this angle is 43.05. So meaning if we want to find this other angle in this quadrant, we are going to move all the way to that point. So which means it will be 180 minus 43.05, and that is going to give us 136.95. You need also to know how to complete the square. That is the first question that we asked here. Express this in this format. To complete the square, what you need to understand is that we are going to take that expression and factor 2, that is 2 from the first two terms. That is exactly what I did here. Once you have factored it out, you are going to remain with this expression, isn't it? This expression now, to complete a square, just take a half of the number that you are having here. For instance, here I'm having 6. A half of 6 is 3. So I'll have x minus 3 squared minus the square of 3. The square of 3, I'm not looking at the sign. Even if it's positive or negative, you are going to minus the square of that number that is inside the bracket. Yeah. So once you've done that, then I'll open the bracket. Remember, this was in the block bracket like that. Then 2 times 9 will give us 18, and 2 times this will give us this expression. So negative 18 plus 14. If we simplify, we shall get our answer as that. Be very sure, we are very sure that there will be a question from completing the square. We cannot discuss anything about that because that question must be there. Then when you are stating the turning points, if you are setting the turning point, minimum point or maximum point, because the purpose of complete the square, of course, can help you to solve a quadratic equation. At the same time, it enables you to know the turning point of a quadratic function. So for you to find the turning point or maximum or minimum point, you go inside the bracket. We are having minus 3. You take the opposite sign. Minus 3, you take positive 3. Then outside here, you take the number the weight is with its sign. So that is going to be minus 4. Now we have P coordinate of this turning point P to be 3 minus 4. Next, in part C, find the equation of L. But we are told that L intersects C at negative 128, negative 128, and also it intersects it at P. And already we know these coordinates. So for us to find the equation of L, we need to find the gradient first. And gradient is change in y over change in x, and that is going to be equals to negative 8. Then once you have gotten the gradient, you can use any of the points because we were having 2 points where the line passes. So you'll use the gradient that you have obtained, which is negative 8, and any of these 2 points for you to find the equation. So this is going to be we are going to use our point as 3, negative 4. So we shall use the point 3, negative 4. And the gradient m is minus 8. That's the gradient of that straight line. So if you use that method, you're gonna get your answer as y minus 8x plus 20, like that. And also stating the inequalities, we can see the region will be below the line, so we're going to say less than, and this one also going to be greater than, then has to be greater than y should be greater than 0, and x should be greater than 0 as well. X should be greater than 0 and the y is greater than 0 as well, and the inequalities for that are well seated here. Before you sit for that exam, you must be able to find, for instance, workout questions where you can be able to find a function when you're given the gradient function. You can see here we are given f prime of x, and then you are supposed to find the value of the function f of x. But before that, this question candidates were expected, yeah, in this question, candidates were expected to find the value of a, but they were given f prime of x, and f prime of x is ax minus 12x raised to the power third. So basically here, candidates were supposed to differentiate, because they were told f double prime, or the second order derivative of this, is 27. So meaning this candidate was supposed to differentiate this again, so that to get f double prime. And if you differentiate ax, you will get a. You differentiate 12x raised to the power third, you are going to take the power down, so that is going to be 12 minus 12 times a third, that's going to be minus 4, and x minus 2 over 3, because 1 over 3 minus 1 will be minus 2 over 3. But if double prime is 27, so meaning you can be able to say all this is equals to 0, rather is equals to 0, then at x is equals to 27. So if you work it out, you are going to get your answers 4 over 9. Part B, hence find f of x. So meaning you are going to integrate the part that we have here, so that you can be able to go back to the function. So integrating that expression, this becomes ax squared, yeah, and this becomes this expression that we have here. And then since we are told that it passes through 1 minus 8, it means we are going to substitute anywhere you have y, or function f of x minus 8, and where you have x, you are going to substitute with 1, and if you work out the value of c that we have here will be 7 over 9, and that gives us the expression. Make sure also you are in a position of finding area of a sector, area of a triangle, arc length, and perimeter. So that is another area that is very key. But in this question that we were given here, what I decided to do is to make use of cosine rule, so that I can be able to find the angle, because you are told show that theta is 1.64. So we were given this length, we were given this length, we were given this length, this angle is given here, then we are supposed to find theta. So for us to find theta, what I did, because I didn't know what was OB, I decided to use cosine rule in order to find this length here, which I got as 1.74. And then I applied sine rule, using sine rule to find one of these small angle. I call this small angle here alpha. Then so that if I get this, I can multiply by 2, so that I can get the entire angle, which is theta. So using this side that we've gotten here, 1.74, now I can be able to find this angle alpha. So what I did, I said sine alpha over the opposite side, which is 1.4, is equals to sine 2 over 1.74. So I found sine alpha to be 0.8 8 to 1. Then to find now theta is 2 times alpha, so that gave me 1.64. The next question that was asked is to find the perimeter in meters to two significant figures. So, but remember, for you to find perimeter of this figure, you need to find the arc length of AXC. But arc length, when you are given angles in arc length, when you are given angles in radians, arc length is usually given by r theta. But which theta are we going to use? We are going to use the theta, the theta behind that, because we have gotten theta is 1.64. But the arc length we are finding is the major arc, so meaning that we are going to take 1.64, we subtract it from 2 pi, so which means that we are going to apply that, and we shall say is r is 0.6 because that's the r of this sector, the radius of the sector, and then times 2 pi minus 1.64, and that gave me a 2.8. With 2.8, now we can be able to find perimeter because we are finding the perimeter of the entire thing, so it will be 2.8 plus 1.4 plus 1.4, and that translates to the famous 5.6 meters. Now let's talk of the area. The area approach I used here is that I ideally worked out the area of the sector that we are having here. I worked out the area of this sector, and then I added the area of the two triangles. I worked out also the area of this triangle here and the area of this triangle here. So when I added all that, I could be able to get now the area of that sector. So that's why you can see I said area of that particular shape will be equals to area of the sector plus the area of the two triangles, which gave me 1.6 meter square. Also, by chance, also another question resurfaced here for completing the square. But now this one you are asked to find, otherwise say the coordinate of m, of course, after completing the square, you get, oh, okay, this is a bit different. So it was quite necessary for us to see how you work it out. So sometimes you may find you're supposed to complete a square and then x, the coefficient of x squared is negative. How do you go about that? Just the same way that we worked in the previous question. Now, in this special case, I'll want you to remember that whenever you are again completing, just factor out what is common. But because you can see this is this became positive, x became now positive, you are going to factor out negative number, so that this is going to be, we factor out -3, we end up having x squared minus 4x. So once you have factored that out, you can say you'll be comfortably dealing with positive x squared inside the bracket. And then now we can say you'll take x, but a half of 4 will be 2. You close the bracket square, then you subtract the square of 2. The square of what's inside the brackets, you subtract it. Even if it was positive here, we will again subtract. That one, always just understand it that way. Then next, we are going to say 4 minus, so you open 3 times whatever that we have here, we get this. Minus 3 times minus 4 is going to give us 12. Then if you simplify, you're gonna get the expression shown here. Then for you to state the coordinate of m, what is m? M is the turning point of curve C, which is the quadratic, which we have completed the square. Now for you to state the that particular coordinate, you're going to read it from here. You take opposite sign of what's inside here, it becomes positive 2. We don't care what is inside, what's outside. I don't start again saying that now if we take this negative 2, then there is a negative here. No, no, no. Don't make that mistake in your exam. You take what's inside the bracket, opposite sign, and that you take what's inside outside here as 16 the way it is. And the coordinate becomes that. Then you are told line L1 passes through O and M. It passes through O and M. So meaning we can be able to find the equation of L1 because you'll find the gradient. Since we are given 2 points, it passes through O, which is the origin, and M. And subtract change in Y over change in X, you get the gradient of that line, and then you can be able to use it to find the equation up as I've highlighted here. Yeah, the next part is find the equation of L2, but we are told that line L1 passes through that. Already we are done with that. Line L2 touches C, yeah, and is parallel to L1. So L2 touches C is parallel to this. So if it's parallel to L1, it means it has the same gradient as L1, isn't it? And then if it touches C, meaning we can be able, if we differentiate the curve, we can be able to get dy dx. Yeah, so dy dx, the gradient of the curve will be equal to the gradient of L2, which is equal to the gradient of L1, because we are told that the line L1 is parallel to L2. But since L2 touches the curve, so it's a tangent, it means that the gradient of L2 is equal to the gradient of the curve. That is the approach that I used there. So I did dy dx of the curve, then I got the expression as 12 minus 6x, and then I now equated this expression to 8 because the gradient of the curve is equal to 8, or the gradient of the line is equal to 8. Then our x coordinate will be 2 over 3. Now with 2 over 3, we can substitute it into the curve equation, and then we get the value of y. So the tangent passes through that point, then we could now go ahead and find the equation of L2. The next concept that you must also be ready to work out is the concept to do with sketching, sketching reciprocal graphs. For you to sketch a reciprocal graph, for instance, let me just give you an introductory part of this. If you have y, is equals, let's say we have 2 over x minus 1 plus, let's say, 3. So this part here, if there is a number added to this kind of function, is going to give you the horizontal asymptote. Meaning horizontal asymptote is going to be y is equals to 3. You take, if there is a number there, if you are given expression 2 over something plus something or minus something, you take that number that is there, you equate it to y. But if nothing is added, maybe you have y is equals 2 over x minus 1, then at that point the horizontal asymptote becomes y is equals to 0. And next, if another asymptote we need to know is the vertical asymptote. The vertical asymptote is usually obtained from this part equals to 0. You just take that and say x minus 1 is equals to 0. So x is equals to 1 is a vertical asymptote. Once you have gotten the two asymptotes, the next business you have is to find the intercepts, x-intercept and y-intercept. What you need to remember, there at the x-intercept y0, at the y-intercept x0. Now let's go to this question. You are given this curve and then they are asking you to sketch. But for you to sketch, you need the asymptotes and you need the intercepts. So which means that for us to comfortably work out the horizontal asymptote, we have said we are going to pick it from this point. It will be y is equals to -9. Vertical asymptote, you are going to take everything that is inside the denominator, you equate to 0, and then it means x is equals to 0 is the horizontal asymptote. X-intercept is where y is 0. If you substitute y 0, then you try to work out this question, you will get x-intercept will be at +1 over 3 or -1 over 3. Y-intercept happens where x is 0, but if you put x is equal to 0 at the denominator here, 0 here, the function becomes undefined. And when the function becomes undefined, it means there is no y-intercept, right? So once you have gotten that, we identify the x-intercept and we identify the asymptotes, the graph will look like that. But for our graph here, this one that I've given you a sample, maybe this is the question that you'll be asked. What is the horizontal asymptote and the vertical asymptote? Horizontal asymptote is at y is 3. So I can be able to say horizontal asymptote is this. And the vertical asymptote is x is equals to 1. So x is 1. So maybe it passes through like this. Yeah. Next, what you need to know is we need to know the intercepts. When at the y-intercept, when x is 0, this is going to be minus, x is 0 here, it will be -2 plus 3, it will be 1. So but it's going to be somewhere, 1 would be here because the horizontal was 3. So if this was 3 here, then 1 will be somewhere here. That's the y-intercept. Then we now, once you have gotten that, we can comfortably go ahead and sketch the graph. The graph will pass that way and the graph will pass that way. So that is what you are supposed to do. So make sure before you sit for this exam, guys, at least you are comfortable, you are able to work out question like that. If you are new to ProfLearn YouTube channel, consider subscribing so that we can be able to grow this channel together. And also, if you know students who can benefit from the same, guys, please consider sharing this video to them so that they can also get to learn this. The last part, the last area, the last question I have for you here is this kind of graph that trigonometric function, trigonometry, and then you are supposed to answer questions also. State the coordinate of P. Remember, this is the cosine graph. So a cosine graph has a period of 360. So meaning that if it goes like that, 360 is here. And I just included the values for that. But we are told that P is the minimum point. P is the minimum point on C1. So if this is 540, then P x coordinate will be 540, but y coordinate would be -5, so that would be 540 minus 5. And then part B, we are told that the point Q lies on a different curve C is true, given that Q is the maximum point of the curve. Maximum point of the curve are these points here. This this blue one I just included to answer the question. Maximum point is this one, maximum point is this one. Now we are told that the maximum point Q is a maximum point, but also is a maximum point with the smallest value of x, where x must be greater than 0. So if this is the maximum point and x has to be greater than 0, so it cannot be this one. The next one is this value here. That's the where Q is, because we are given that condition, a maximum point with smallest x but greater than 0 is 360. So it will be 365. The coordinate of Q will be 365. But now, since it's -2 here, we shall take the amplitude 5 minus 2, which now we shall get as what? As 3. C2 as the equation -5 cos x. -5 cos x is a reflection of this graph that we have. So the minimum point here will be reflected on the x-axis. It will be the maximum point there. So our smallest maximum point greater than 0 for Q will now be 180. So it will be 180,5, and that's what we are supposed to do at that given point. Up to that point, guys, if you have gotten value from this particular video, consider subscribing so that anytime I'm going to upload more tutorials, you'll be notified. See you in the next video. See you guys, and good luck in your exam. All the best.